Hello, this is Mr. Stein, and in this video we're going to go over the questions from the Mastery Items worksheet for week 11B. Alright, question number 1. The formula E equals mc squared is a very famous formula by Einstein. It states that the total energy in an object is equal to the mass of the object times the speed of light squared. The speed of light is always a constant of 300 million meters per second. Determine the missing variable. So in this equation, we always know C. The question is, do we know E and have to find M, or do we know M and have to find E? Which one? In our first question, we know E, we have to find M. Okay. Now, 300 million, this gets kind of annoying to work with in a calculator. So I'm going to show you a trick that I have on one of my calculators. I have many different calculators on my iPad. A trick that I have to make this a little bit easier. So the first thing we're going to do is we're going to write out our formula. E equals mc squared. Now, I'm going to manipulate this formula so that m is by itself. So I want to isolate my m. So I divide both sides by c squared. These will cancel out, and we get m is equal to E divided by c squared. So to figure out my mass, if I know my energy, I just take my energy and divide it by c squared. So in this one, I do my 5 divided by 300 million squared is equal to m. Now, this is going to be a really tiny number. I have a calculator, and I'll show you. I use a calculator called Solver, and in Solver, I've made a variable c, and c is always equal to 300 million. So when I want to do this question, I can do 5 divided by, type in c, and then square my c, and I get the answer. So I did 5 divided by c squared. So instead of having to type in 300 million meters per second every time, I can just type in c, and the calculator knows that c equals 300 million. Now you can use your normal calculator to do 5 divided by 300 million squared, and you should get this number, 5.6 times 10 to the minus 17, a very tiny number. 5.6 times 10 to the minus 17. Just like that. What's important, though, is that you can manipulate a formula to isolate a variable. Letter B, we know the mass, and we're asked to find the energy. So in this one, what we're asked to find is already isolated. Mass times the speed of light squared. So energy is equal to 4 times 300 million squared. Now I go to my calculator, and I do 4 times c, and then I square it. 4 times c squared, and I get 3.6 times 10 to the 17, a very big number. So now you can see a small mass gets us a huge amount of energy, whereas a small amount of energy gets us a very tiny amount of mass. All right, question number 2. Determine the volume of a square-based pyramid that has h height equal to 55 millimeters and side length of equal to 3 centimeters. You should already notice something wrong in this problem. We have different units, don't we? Let's change our height to match our units for our length. So this should be 5.5 centimeters. All right, now, I don't need to draw this out because I know that I have my perpendicular height, which is important, and I have my side length, and it's a square-based pyramid. So the bottom is a square, so all the lengths are 3 centimeters. So I'm just going to start working with my formula. Volume of of a square base pyramid, or rectangular base pyramid, is equal to the length times the width times the perpendicular height divided by 3. The divided by 3 is because it comes to a point. So the volume is equal to, I think it's what, 3 times 3. 3 times 3 times 5.5 divided by 3. Now, this, because it's all multiplication in my numerator, I can actually do some simplification. I can cancel those two guys out. My volume is just going to be 3 times 5.5. And 3 times 5.5 is 16.5 centimeters cubed. There's my final answer. All right. Question 3. Find the length of edge or size of angle marked X in each of these diagrams. All right, so we've got a couple of triangles here. Here's our first triangle. It's a right triangle. We only know one piece of information, so we can't use that triangle first. Here's our second triangle. We know two pieces of information, and that's the triangle, so we can figure out the rest of that triangle. Anytime you have a right triangle with two known pieces of information other than the right angle, you can solve the rest of the triangle. So this is the angle. This is my hypotenuse in this blue triangle. And this is my adjacent side. So ka toa. Ka, adjacent and hypotenuse. So for the blue triangle, we're going to use cosine of our angle is equal to our adjacent side over our hypotenuse. So cosine of 52 is equal to 28 over our hypotenuse. Now cosine of 52 is just a number, is equal to a fraction where we don't know the denominator. So these two guys get swapped. So we get our hypotenuse is equal to 28 divided by cosine of 52. So I do 28 divided by 52, cosine is equal to 45.5. It's the hypotenuse. It should be the longest side in the triangle. So I write down here 45.5 centimeters. All right. Now we know two pieces of information on the yellow triangle. So this is the angle we're trying to figure out in this yellow triangle. Related to that angle, we know the opposite side and the adjacent side. So opposite and adjacent is what we know. So we're trying to figure out the angle. So opposite and adjacent. So ka toa. Toa, tangent, has opposite and adjacent in it. So we write out tangent of our angle is equal to our opposite over our adjacent. So tangent of our angle is equal to our opposite side, 45.5, divided by our adjacent of 23. Now I've got the more precise number for 45.5 in my calculator, so I divide it by 23. I get 1.97737. So tangent of theta is equal to 1.977, and I have the more precise number in my calculator. So now I do the inverse tangent to figure out my angle. And I get 63.17, or our angle is 63 degrees. So this angle right here is 63 degrees. Usually with angles, we keep them in the whole numbers. We don't go to decimals too often unless it's asked. All right. Well, I hope that was helpful. If you have any questions, please put them in the comments below or contact me directly. And thank you for watching.